The degree of a polynomial. Tony. The degree of a polynomial. The reason why we are learning the word degree is because we need to know how to arrange and categorize polynomials. Because they create different graphs. Different types create different graphs when you graph them, and we'll start doing that later on. And so some of them you may be familiar with, like a parabola. You guys know that a parabola is like...
Problem?
You don't need to know it yet, but a parabola is an example of a graph of degree 2. So let me explain to you what degree means. The degree of a polynomial is the number of variables present in the term with the most variables. So the term in a polynomial that has the most variables, that number of variables is the degree.
What about in a monomial?
In a monomial, the monomial, with however many variables are in that monomial, that's the degree. And so over here, it may not be all that obvious at first, because here, when we look at this 2xy to the third, most of you guys will see two variables there, an x and a y. However, there are more than one y. There are actually 3 y's all multiplying together. And so you have 1 y, or you have 1x, 3 y's, which means it is a degree of 4. There are 4 variables there. Degree of 4. Someone quick repeat or explain to me in your own words exactly what I just explained. Go ahead, Ellen.
I think it's because the y is, the exponent is like to the third and cube, so there's like 3 of them, plus the x, so there's 4 altogether.
Exactly. You just got an O from somebody. So good, thank you.
Do you count the x?
So now we look down to the other terms in this equation. And each term has its own, you could call it degree. And so the degree of each term that's one thing. And then there's the degree of the polynomial. The degree of the polynomial is only defined by the term with the highest degree. Okay? And so to explain that through this example, here we have one variable. So degree of 4. Here we have one variable, degree of 1. Here we have no variables, so 0. You choose the highest one, and that is the degree of the entire thing.
So if there's no variable, but then the number has an exponent, it's like, let's say, as in the homework, it's like 4 to the 7th power. What would you do?
If there's no variable, there is no degree. And so for those of you who never really learned what a monomial or polynomial is, and you've just been hearing me say it over and over. Monomial, the monomial is one term. And a polynomial is
More than one term.
yeah, more than one term, or multiple terms, or many terms.
Isn't it like connected with addition, subtraction, multiplication, and division?
Yes, exactly. And terms are separated by addition and subtraction signs. And so the example where we found the degree, this has a degree of 4, because that's the number of variables in that highest term. But the number of terms is a different question. And that's something that I think you have to differentiate between in a question on homework. So here you have 1 term, 2 terms, 3 terms. And so if the question were to say the amount of terms and the degree of a polynomial, this one right here would be 3 terms, 4th degree. Alright, and all this just goes to tell you how to write a polynomial. here you have a long polynomial, and there's a few guiding rules on how to write this in perfect form. The first one is highest degree term first.
Second.
And it goes from highest to lowest, and so as you go further right, it goes lower. So, lower degree as you go right. And then lastly, suppose you have two things with the same degree. Here you have two x's in this term, here you have two y's in this term. What one do you put first?
X.
What do you think, Sadie?
The letter that goes first and most.
Exactly. When you have the same degree terms, it's alphabetical.
X, Y, Z. You just had to think of X, Y, Z.
I wrote it there because these two have the same degree. Alright, alphabetical if same degree. We need to clarify now the difference between adding and subtracting, multiplying and dividing and all that stuff, because there's going to be some questions on this homework and in the test that'll look like, let's start with B, because I think that addresses exactly what Maddie is talking about. Sometimes you're multiplying, where you use the FOIL method, like x plus 3 times x plus 2. And then other times you're going to be adding or subtracting. And you guys did this earlier on this year. These two, x plus 3 plus x plus 2. And you got to think of what to do to get rid of the parentheses. Over here you multiply, you FOIL to get rid of the parentheses. Over here you don't FOIL. What you'll notice is that you've got a plus here, and as I explained it earlier on in the year, when you have plus, it's kind of like it's when you distribute and you don't have a number in front of the parentheses. And so what you do is you picture a invisible 1. Okay? So imagine that there's an invisible 1 here in front of those parentheses, and an invisible 1 here in front of those parentheses. You would distribute those, and they wouldn't change anything. They would just be 1 times x, and you'd have x, and then 1 times 3 is 3. So to get rid of these parentheses, you actually don't really have to do anything. You can just erase them. And so you have x plus 3 plus x plus 2. Now, suppose that there's a minus in between them. In this case, you have to remember that subtracting a grouping means you have to distribute the negative. Okay? So, in front of this one, there's an invisible 1, but with the minus in front, it's a negative 1. And so when you're distributing that negative 1 to everything on the inside. So here you have x plus 3, and then distribute this negative 1 over here, minus 1 times x, it's minus x, and then negative 1 times positive 2 is negative 2. Now, what you may have noticed is that I only distributed it to these parentheses on the right. These parentheses on the left, if you put the invisible 1 in front of them, it's a positive 1. Since there is no negative sign in front of these.
But then do you just, what do you do after that? What do you do with this?
What do you do if there's no parentheses? Then it's just adding and subtracting. So then you're looking for similar terms, x and x, 3 and negative 2. See?
Simplify it.
Yes. And so with both of these you can simplify further. You got x plus x is 2x. 3 plus 2 is 5. And then this one is a bit different because you're taking away an x and you're taking away a 2. So x minus x is just 0. And then 3 minus 2 is negative, or yeah, plus 1. There you go. So the answer would be 0 plus 1 or just 1. So the purpose of this is to clarify the difference between FOILing, adding, and subtracting polynomials. Now up on letter A, there's a second mistake or there's a second way that you guys could possibly make a mistake, which is this. This first x plus y squared is a FOIL problem. If you write it out longhand, what squared means is you're multiplying something by itself. So you have x plus y times x plus y. And then this one right here, multiplying it by itself, is xy times xy. So over here, you're just multiplying everything through. So it would be x squared, y squared. And then over here, you're FOILing. I'm just going to write FOIL there. You guys know how to do it. When you did the FOIL method, let's give an example of two-termed polynomials. So x plus 2, x plus 3. When you used the FOIL method, you took this x and you multiplied it by both of those numbers. You kind of distributed it to the second two numbers. And then you took the 2 and you multiplied it to both numbers, distributing as well. So if we distribute each thing in here to each thing in here, how do you think we'll write it out over? How do you think we do it over here when there's 3 terms? Luke?
Do you just like distribute the x to the different terms, to the different monomials in the other one, or terms in the other? Yeah, and then you do the same with the 2.
Yep.
And that's.
So the way I kind of see it is you draw. You kind of draw two like rainbows on top. That's kind of a weird way of thinking about it, but that's kind of what I see when I see these lines. You draw one going from the x to all the terms over here, and then one going from the 2 to all the terms over here. Exactly. Rainbow reflection in a pond. That's how you'll remember to do this correctly. And then down here you'll do the same thing. It's you take this first term, you draw the rainbow to each term on the other side, and then the rainbow to each term, like so. X to x squared is going to be x to the third. X to 2x is going to be 2x squared. X to the 2 is going to be 2x. So we got the first 3 done with. Now we distribute the 2. 2 to 2x is going to be 4x. Oh, I'm sorry, I missed one. 2 to the x squared is going to be 2x squared. 2 to 2x is going to be 4x. And then 2 to the 2 is going to be 4. And now you start combining similar terms. All right. Let's see here.